But first, who the heck am I and why the heck should you care about what I have to say? Answer is you probably shouldn't, but since you're here, you're gonna have to listen to it anyway. My name is Sam Ruben. I'm one of the co-founders of Mighty Buildings, formerly the Chief Sustainability Officer, and currently serve as the Senior Sustainability Advisor. Stepped back into that role just coming up on a year and a half, 2 years ago, to focus more on policy in California, sorry Alex, including AB 2446 that was signed into law last year and AB 43 that was signed into law this year. 2446 is the first bill in the country to require mandatory reductions in the embodied carbon of building materials, and for both private as well as public, so it goes beyond the Buy Clean Acts that we see in a number of states and at the federal level. Additionally, AB 43 is a follow-up bill to add a trading mechanism to that, to incentivize, both to add flexibility for compliance, but also, more importantly, to incentivize over-compliance. So similar to the low-carbon fuel standard that was critical in allowing Tesla to exist as a company for many, many years, and also help drive the adoption of EVs and building the momentum to what we see today. There we go. So the reality is that housing in the climate crisis is a two-way street. The simple fact is that housing is one of the most directly impacted realities of wildfires, of rising sea levels, of hurricanes, of tornadoes. Largely, the biggest impacts are on the built environment, and it's globally. It's really wherever you are, you're already seeing these impacts in many cases. There. Well, maybe. There we go. Yeah. There we go. So, and at the same time, the built environment is one of the biggest drivers of the climate crisis. The reality is that 34% of all final energy consumption in 2021, best data I have, this year's report hasn't come out, is tied to the built environment. 37% of all final emissions tied to the built environment. So that means we're looking at a very significant opportunity to leverage the built environment for good and as a tool to help address the climate crisis. And the reality is, unfortunately, we're falling a bit behind. This is the tracking of getting us to a zero carbon building stock. And as you can see, we had a great year in 2020, which unfortunately we couldn't maintain, but it does point to the reality that if we really want to, we can do this. The problem is, do we really want to? But as you can see, we're falling further and further behind of where we need to be with every year. Even though our numbers are getting better, they're not getting better fast enough. And so to really do this, we really need to rethink what it means to build and how we build and what we build with. So 3D printing, I'm sure you guys have heard a lot of the hype. It's getting a lot of news coverage, but it really is slowly starting to come into its own. We're seeing more and more opportunities in the built environment to deploy 3D printing, whether that's a bio-based home that the University of Maine printed with 3D printing materials derived from wood and other sources, whether it's what we're doing at Mighty Buildings to deploy the world's first zero-net energy community, 3D printed zero-net energy community in Southern California, what Icon's doing in Texas, building a 100-unit Lennar development, what they're doing in Denmark, 3D printing student housing. More and more, it's really starting to come to the fore and pop up in lots of places that we weren't seeing it before. And importantly, the standards are also catching up to innovation. Because obviously, one of the critical aspects of the built environment is that these are the roofs over our heads. And the unfortunate reality is that the building codes are written in blood. And I know that sounds a bit extreme. It's not. We generally don't change the codes until something horrible happens. In the 3D printing space, we're trying to take a different tact. We're really approaching the standards making very, very early, and not just us at Mighty Buildings, but really in the entire industry, because we want to make sure that there are standards to show how it can be done correctly and how it can be done the right way that's going to be safe. So we worked with UL to develop new standards. I also helped lead ASTM's subcommittee developing new standards for 3D printed construction. And then we're also seeing a number of states and governments across the world beginning to develop building codes for 3D printing construction to really help guide that and ensure it's being done safely. So what are we doing at Mighty Buildings, and why am I up here talking about this? Well, we believe in a building that's better for people and better for the planet. So we're a technology-based company in Oakland, California. We use innovative 3D printing to manufacture premium, climate-resilient, sustainable homes. So one of the cool things you'll notice here, there's the pointer. See that light? that's the cool part, the really, really cool part about what we're doing. Most 3D printed construction you see is concrete and is effectively just pouring concrete differently. The first 3D printed concrete building was made in 1934. So not exactly the newest technology, though great things are happening in the concrete space. What we're doing is we're using photoset composites. So we're able to bring products to market that are as strong or stronger than concrete, depending on whether we're talking compressive, tensile, flexural strength properties, while being 5 times lighter and more durable. And so the key is that we are using material that hardens with light almost instantaneously. This also opens up significant design opportunities. And so we're also using this, we're able to unlock advanced manufacturing at scale. We're able to use a panelized system that accelerates development by more than 3 times. And I'll get into a little more of that in detail later. And also unmatched building performance that is incredibly climate resilient. Because the reality is, as we're addressing the climate crisis, we have to build housing that's going to be resilient in the face of what's coming down the pipeline and is already here. Because the simple fact is, even if we turned off all carbon production today, we're looking at decades of cascading impacts from the feedback loops that we've already triggered. So we were founded in 2017, originally based in Redwood City on the peninsula, and then moved to Oakland in 2019. Our focus is on construction speed and quality, and longer term we are looking at affordability, but for the time being really focused on that quality and that speed, because the simple fact is you can have a higher upfront cost if you can deliver your product significantly faster, because it allows developers money to turn faster and investors get their money back. So you're able to balance that a little bit. Also efficiently scaled production. One of the things that we're focused on is microfactories. So rather than just ship everything from our primary production facility in Monterrey, Mexico, we're actually going to be deploying factories into existing warehouse space where we have demand. So that allows us to significantly reduce the carbon associated with transportation, allows us to create not only homes for a market, but also jobs, and also allows us to explore opportunities for localizing aspects of the supply chain. A great example is we use recycled glass as 60% of the filler of our material. We're in conversation on developments in the Middle East. We'll likely replace that glass with desert sand. So it allows us to kind of look at those opportunities in some really interesting ways. Then also, because we're using a digitally driven design process that uses a digital manufacturing, we're also able to do design customization pretty easily. Same with the panel system that lends itself to a lot of different possibilities. So the reality is that customer expectations continue to rise while developers are facing more and more new challenges. We're being pressured to build more faster and more profitably, despite the fact that labor costs are rising. The amount of skilled labor is dropping. The volatility of the supply chain is going insane because of the COVID crisis, and it still remained pretty volatile, even though now we're coming out of things a bit. Top of that, and then also just more and more demand for sustainability from your premium home buyers. So with our platform, we can, same platform, same panel system, we can build almost any typology of home. Currently, what we've delivered so far is single-story, single-family. Next projects are going to be 2-story, single-family, as well as townhouses, and that plan on moving into apartment buildings as well. So really, all with the same panel system. Just depends how we configure it, how we put it together. So also elevated design and quality. So I just want to say, these are actual pictures. These are not renderings. Some of the things you see in this deck are, these are not. So we're actually able to do that with a 3D printer, which I always get really excited about. And same with this. These are not renderings. Those are all actual panels that we have 3D printed using our technology. Really opens up the possibilities in the design space and really allows for a lot of different looks as well as kind of unique configurations. Even though everything you see here is flat roofed, we can use any roof type, don't worry. It's just most of these products were developed for markets that often are using relatively flat roof systems. And it's important that we're climate resilient. And that not only that we say it, but that we have the certification and the testing to back it up. So one of those key aspects is that we've done significant work to pass Miami-Dade's hurricane code, which is the most stringent hurricane code in the world. I gotta say, it's a lot of fun to watch 2x4s get launched at your wall and bounce off. And so one of the keys there is the fiber reinforcement that we deploy as a part of our printing process. So all of our panels currently use continuous fiber, though we are moving to chop fiber to open up even further possibilities. Earthquake resistance. I remember we actually did an actual shake table test, went past a 9.0. There was a crack in one corner of the panel, and that was it. So we're really, like, everything is super over-engineered because we're looking to build, because part of it's we're building in California. And we actually chose that because it's one of the hardest places in the world to build. We didn't want to go somewhere like Texas where they'll let you build anything, because we wanted to easily go to other places afterwards. And so we started with California, made sure we could build there. Then we started looking at the Caribbean, Florida, Texas, places that start seeing hurricanes, Middle East. And at the regulatory level, that transition's been pretty easy because of what we've been doing here. We've got assemblies that can achieve 1 hour and 2 hour fire ratings. We've got a Class A flame spread rating on that. 50-year plus expected lifespan of the buildings. And I believe we did accelerated aging tests out past 75 years. And at that point, it was like less than 10% degradation in the strength, which really isn't an issue, given that we do 3x safety buffers on everything. It's resistant, it's microbial resistant. It's also water resistant, it's hydrophobic. So we don't have to worry about places like the tropics, or if your house does get flooded. Like, having spent a few months in the New Orleans after Katrina with Red Cross, digging out houses, like, the bones were fine. The issue was the mold that, because of the water penetrating everything. If that was one of our homes, wouldn't be a problem, because the mold can't grow. And similarly, we go beyond California's very stringent Title 24 energy efficiency codes, and also have significant acoustic insulation as well. And so, I mentioned before, 3x faster completion. We can go for a single family home, we can go from a blank slate to fully installed in 2.5 months, once permits are in hand. So let's see if this should work. Oh no. Well, anyway, if that video worked, you'd see this really cool video of going in 4 days, going from a foundation to a fully stood up house. Because that's one of the really exciting advantages of offsite construction, is that while the foundation's being poured, while the utilities being put in, while it's being done, we're printing the panels for the home in our facility. So as soon as that foundation's ready to be built on, the unit's going up. And so that can significantly increase your time to market and move and get people into those houses much faster. And yeah, if you can actually visit our homes, we've got that first development in Desert Hot Springs in Southern California, outside Palm Springs. And then a lot of integrated innovations for sustainable homes. As I mentioned, we're using non-concrete materials, 60% recycled, 5 times the strength profile of reinforced concrete. Because it's offsite and because we're using 3D printing, it's a we can eliminate 99% of the waste associated with a traditional build. And just so you understand what that looks like, a traditional build is 3 to 5 pounds of waste that goes to landfill per square foot. So that's not insignificant. Also, as the sorry, got excited. Wrong button. Parametric design, 3D print customization. We're actually deploying that as for a visitor center for the Buckminster Fuller Institute's Buckminster Fuller Dome Home. So very excited about that project. We also incorporate a gray water system that utilizes a green wall technology. So it's a nature-based gray water system, which is, we've got a great partner. I think that's Leapfrog is the name of the company that we're working with on that. And as mentioned, we're also doing net zero energy with incorporation of solar and storage, while being cost competitive against traditional construction that's not net zero energy. We're also working with Habitat for Humanity and Lawrence Berkeley National Laboratories on a CEC California Energy Commission funded project to do low carbon townhouses. And a part of that, we're developing a cool room concept, where for very low cost, we can actually have a room that's going to be maintained at low temperature, which is critical during power outages in high heat areas, particularly as those extreme heat events become more and more common. And also, digitally enabled general contractor project-specific intelligence for real-time decision-making, so we incorporate sensors into all of our things in our production process. And for the 3D printing is just part of it. And actually, I think I forgot that slide. But so along with the 3D printing, we also use robotic automation for pouring of the foam insulation into the interior cavities, as well as for milling, which allows us to get sub-millimeter tolerances for the assembly, which makes on-site assembly go perfectly every single time. Additionally, it opens up opportunities on the design side as well, because even though we haven't done this yet, there's no reason we couldn't use that milling opportunity to make it look like wood, make it look like brickwork, or siding, and match those traditional aesthetics while also opening up opportunities for styles that no one's ever seen before. So say you want to put your logo on the wall. Well, we can have that be a part of the wall and not need to be painted. Like fun stuff like that. It really opens up whole new possibilities. And then we're also partnering with companies like Ori Living, Bumblebee Space, and others to create convertible spaces that the furniture moves around depending on the use case. And also working with Habitat Humanity to design and develop a prefab labor training system to help increase the amount of workers out there who are trained in offsite construction and assembly, because it's a critical aspect of solving the housing crisis. It really doesn't like me. As mentioned, low waste, low carbon, resilient, focused on cradle to grave sustainability. So right now, we're working on developing a system to be able to test and reuse panels as our ideal end of life solution, because that's going to be the lowest energy. But we're also looking at other opportunities such as grinding up the material and using it as filler in new material, as well as advanced chemical recycling, pyrolysis, and other solutions, because we realize that we can't, even though end of life isn't until like 70 years from now, 100 years from now, we need to be thinking about it now. And part of why we do that is because we do whole building life cycle assessments for every one of our designs. We also do life cycle assessments for every one of our material formulations, which is critical, and we also then get them verified. Because you've heard a number of people talking today about the importance of good data. We're trying to do our part to help create that data. And the realization that it was hard to get good data from from our suppliers is a big part of why we actually push for AB 2446, because the first requirement is that it requires life cycle assessments and EPDs as the starting point to then create a baseline for reductions. And if you want to hear more about LCAs, Robert's going to be giving a great talk tomorrow. Highly recommend it. They're fascinating and amazing, and one of the most powerful tools you can have in your sustainability playbook. And with that, I'm done. Thank you very much. And I think I even have like 1 minute for questions. All right, I got a shrug, so we'll take that as a yes. Any questions? All right, oh, we got one over here.
So if you are 3D printing, let's say, a fireplace for rockery or brick, or you said you could do any sort of patterning. Mm-hmm. Like with laminated floors, there's like 6 or 7 different templates.
Yeah.
You got to stagger them. Is that the same way with 3D printing? Or if you say you got a 20-foot vertical fireplace that you want to do a 3D printed rockery?
No, I mean, the cool thing about 3D printing is you can really make it do anything as long as you've got the right design file. And that's the other cool thing, is you go from one design to another design without changing any of the equipment. You just change the file that you're utilizing.
The video that didn't show about the timing.
I think you can find that on our Vimeo or YouTube channel.
Okay.
Just so you know.
That's wonderful. I'll definitely look at that. The question is, at what point, like let's say you're pouring a foundation or you're getting permits or whatever, at what point can you start, and how long does it actually take to prefab, let's say, one panel? And if a home is, I don't know, maybe 20 to 30 panels, like how long does it take to print that?
Yeah, so we can start the printing process pretty much in parallel with the foundation, because that pouring and curing is going to take minimum 2 weeks usually.
2 weeks per panel?
No, pouring, curing, foundation. So I think we can print an entire panel depending on the size, because we do corner panels, 2-foot panels, 4-foot panels, and 6-foot panels. So timing depends. I think that 6-foot one, all told, is an 8-hour process to print and cure. But we also are running multiple printers. And then with the microfactories, to increase capacity, we just add additional production cells. All right, and if you have questions, I would love for you to join me next door for the roundtable. It's going to be a wonderful conversation.
Thank you. Just before everybody leaves now for the roundtable discussions, one little thing. We got notice from a couple of guests that they have to leave tomorrow in the afternoon quite early. So we decided to actually compress tomorrow's schedule into the morning session, if that's all right with you. So basically we will have a little bit shorter presentations and a little bit shorter discussion rounds, but all the content, all the speakers will be there, so nothing will be lost. We are right now updating